everybody! Today's practice problem comes from Economics, Principles and Applications, 6th edition, by Robert Hall and Mark Lieberman. Today we're going to be doing Chapter 7, problem number 4. The problem starts by saying that this table here gives the short-run and long-run total costs for various levels of output of Consolidated National Acme Incorporated. And then the first part of the question says which column, TC1 or TC2, gives long-run total cost and which gives short-run total cost. And what you'll notice here is that, you have a Q here. This is just for quantity produced, right? And technically in the textbook, this was a capital Q, but I like to use the rule where if we're talking about output of a single firm, we use little q, and if we're talking about an output of an entire market, we use big Q. So I changed this, I made this a little q. And then you just have two rows of total costs. And in order to think about which one is which, we need to understand what the difference between the short run and the long run is. From a production standpoint, the difference between the short run and the long run is which inputs are variable and which ones are fixed. And we say in the long run, or if we're taking a long planning horizon, all of our inputs are actually variable. So if we think about what our inputs are, we have labor, we have capital, all this stuff. And over a long enough planning horizon, we can actually change the amount of any of those inputs. In contrast, in the short run, or if we're taking a short planning horizon, some of our inputs are actually fixed because we decided on them, we signed a lease, we did something, and we can't change that in the short run. And typically what we think of in the short run is that the amount of capital is fixed and the amount of labor is variable. And you can roughly think about that as in the short run, we've chosen a particular size of plant or factory. So we have this factory, it's got a given number of machines, stuff like that. And the choice that we have to make for ourselves in the short run is how many workers we want to operate that factory. And that's generally a helpful way to think about it. In terms of costs, what this means is that in the short run, we have fixed costs, that we've paid those upfront fixed costs to even be in business in the first place. And those fixed costs, not surprisingly, corresponds to that fixed input or that cost of that fixed size of factory. And then the variable costs would be labor, materials, stuff like that. So we can think about, in contrast in the long run, because all inputs are variable, and we're just asking when we think about long run costs, what is the cheapest way of producing each of these quantities of output when we can change around everything, our labor, our capital, our production process, etc. We're going to get a different answer, that there are no truly fixed costs in the long run. So we can look at these numbers in one of two ways. The first way that gives us our answer is that, well, if there are no fixed inputs in the long run and everything is variable, then by definition, all costs are going to be variable. And it must be the case that in the long run, the long run total cost of producing 0 units has to be 0, because we would just choose a level of labor of 0 and a level of capital of 0. And that by itself actually tells us which one of these is long run and which one of these is short run. So I can take my handy marker here and say, actually, this one's got to be long run, and this one's got to be short run. Because in the long run, the fixed cost isn't going to play into this quantity of 0, and the total cost of producing no output is actually just going to be 0. Whereas in the short run, we have a sunk cost that we can't get away from, and that fixed cost is present even when our production quantity is 0. The other thing that we could notice, or the other way that we could think about this, is we could notice that the long run total cost, because again we have more flexibility, is really the minimizing value of all the different sizes of factories we can have. So what size of factory minimizes our total cost for a given production quantity. Whereas our short run total cost basically says, well, we're stuck with this size of factory. How much is it going to cost us to get this much output out of it? And because we have that flexibility in terms of plant size in the long run, it has to be the case that we're able to plan and achieve greater efficiency when we're taking a long planning horizon than when we're taking a short planning horizon. And what this translates to in terms of cost is that it has to be the case that in the long run average cost has to be weakly less than the short run average cost. Because it's never, in the long run, when we have more options in terms of how to operate efficiently, it doesn't make sense for our long run cost to actually be higher than our short run cost for any particular quantity. So what we can see here is we can again look at these numbers, but this time look all the way down, and we can see that our long run numbers, sometimes they're the same. Here they're the same, for example. So it must be the case that whatever size of factory we chose in the short run is actually the most efficient way that we can produce 3 units of output. That's what it means when these two are the same. The rest of these numbers are not the same. So what that means is that it must be the case that there's a better way of organizing than what we have in the short run to produce 1 unit, to produce 2 units, and so on and so forth. Because we can see that our long run total cost for those quantities is actually below the short run total cost. So even if I didn't already know this, I could look at my cost numbers and say, well, it doesn't make sense for our long run total cost at a particular quantity to be greater than the short run total cost of that quantity. So even just looking at, for example, these guys here, that still tells me that the column on the right has to be my short run total cost and the column on the left has to be the long run total cost. The next part of the question just says, for each level of output, find short run total fixed cost, total variable cost, average fixed cost, average variable cost, and marginal cost. So I spared you the pain of doing these all out one by one. So if you want, you can just pause here to check your work. And we'll go through and we'll at least talk about what the formulas are for all of these, right? And if you want a video that goes through all of this in detail, there's an earlier video on the cost of production that actually goes through these one by one. So you can check that out. So here we have, first off, we have total fixed cost. And we notice, of course, given its name, that fixed cost is fixed, meaning it's the same regardless of what quantity is. So then it just becomes a question of thinking about, well, how do we figure out what that first total fixed cost is? And in the short run, we know that our fixed cost is going to be that cost that's present even when our production quantity is 0. So I could just go over here and say, oh, well, in the short run, I have a cost of 350 at a quantity of 0, so my fixed cost, or my total fixed cost, must be 350. And then I'm going to just write that all the way down. We can calculate variable cost by just noticing that total cost has to equal total fixed cost plus total variable cost. So we could say that this guy has to equal this plus this. So I could just subtract off total fixed cost from each of these total cost numbers to get total variable cost. So we start seeing that, total variable cost at a quantity of 1 is just 400 minus 350, which is 50, and so on and so forth. So we could say here that total variable cost, if we wanted to give it a formula, we could say that this is total cost minus total fixed cost, right? If we wanted to look at average fixed cost, well, when we're saying average in the context of the cost of productions, it just means that we're dividing by quantity. So then average fixed cost would have to be total fixed cost divided by quantity. And you can see that for the first one, that's kind of trivial because we're just taking this total fixed cost and dividing by 1. But then we can take another example. For example, a quantity of 5. We have a total fixed cost of 350 divided by a quantity of 5. That's going to give us an average fixed cost of 70. And you can go through and you can notice what I did here, and this is the convention that I used for all these numbers, for the averages. For a quantity of 0, the average and the marginal cost don't really make sense in one case because, or in these cases for averages, because I would be dividing by 0 and get something weird. And in a case of marginal cost, there's no real incremental cost of that 0th unit, so that doesn't really make sense either. So I just put these guys here like this. And then some of these numbers are actually rounded and others aren't. And the convention that I use is if I had to round, I rounded to the nearest dollar. But if something came out to a particular number and I didn't have to round it, I wrote out all the decimal places. So you'll notice here that that results in either having 0 decimal places or 2 decimal places. So that's just what I did as a convention. We can notice now average variable cost, in the same vein, is just total variable cost divided by quantity produced. And again, for a quantity of 1, that's trivial because we would just be taking total variable cost of 50, dividing by a quantity of 1. But we could look at another one. We could say, here, for example, we have a total variable cost of 210 divided by a quantity of 5. That's going to be 210 divided by 5, or 42. And you could keep doing that. And you could also notice that total costs, so total cost, total fixed cost, total variable cost, all these guys have units. At least if we're dealing with US currency, they all have units of dollars. So we can say this is in dollars, this is in dollars, and this is in dollars. But then our average costs here are in dollars per unit produced. So we could say that this is in terms of dollars per unit. This is in terms of dollars per unit. And this is in terms of dollars per unit. So lastly, we have these marginal cost numbers here. And we know that the formula for marginal cost is the marginal cost is just the total change in total cost divided by the change in quantity produced. And when we have quantity numbers that are just increasing by 1 each time, we can simplify this and say actually the marginal cost then is just the change in total cost associated with producing 1 more unit. And what that translates to here is that the marginal cost at any quantity is just the total cost of that quantity minus the total cost at the quantity that was 1 less, right? So we would say the marginal cost of the first unit is just 400 minus 350, or just 50. Technically speaking, if we were putting it into this formula, we would see that the marginal cost of that first unit is 400 minus 350 divided by 1 minus 0. But we're just going to be dividing by 1 every time. We could do another one, and we could see the other extreme down here, that the marginal cost of the 7th unit is going to be the total cost for a quantity of 7 minus the total cost for a quantity of 6. So 735 minus 635 is just 100. So our marginal cost there is 100. And you'll notice what I did here. First of all, I introduced marginal cost and defined it as the cost of the last unit produced. So when we're talking about marginal cost, technically there's some ambiguity. If I say, for example, what's the marginal cost at a quantity of 4? It's not entirely obvious whether that means what's the incremental cost involved in going from a quantity of 3 to a quantity of 4, or from a quantity of 4 to a quantity of 5. Now, more often than not, it means going from a quantity of 3 to a quantity of 4. But sometimes we make that explicit in our table by actually putting the marginal cost numbers rather than directly with a particular quantity. Sometimes we put them between 2 quantities. So we put it like here to indicate that we're going from a quantity of 3 to a quantity of 4. But any way you do it, you're going to get these numbers here. It's just a matter of how they're staggered in your table. The next part of the question asks, at what output level would the firm's short-run and long-run input combinations be the same? So, how can we think about that when we're only given cost information? Well, if we were to compare the long-run total cost and the short-run total cost, well, just logically, it must be the case that if for a given quantity of output, those total cost numbers for the short run and for the long run were different, it must be because we're using different combination of inputs in the short run and the long run, right? Well, the flip side of that then is that we're using the same combination of inputs in the short run as we do in the long run when the total cost of producing a particular quantity of output is the same in the short run as in the long run. So taken that way, we can see here, we're like, oh, well, quantity of 0, clearly these two costs are different, so we must be doing things differently to get those different costs. Similarly for a quantity of 1, quantity of 2, but then what we notice here at a quantity of 3, is that the total cost, both in the short run and in the long run, of producing 3 units is the same. So it must be the case that whatever size of plant or factory or whatever we chose here was actually the optimal plant size for producing 3 units, as we said before. Because even when we have more flexibility in the long run and we could change plant size, we could change the amount of capital, etc., we're not doing so. And we can tell that we're not doing so because our cost isn't changing, right? So here, this is one point where we're actually using the same mix of inputs in the long run as in the short run. And then we could keep looking to see whether there's anywhere else where that's going to be true. But we notice here as we keep going that all the other production quantities have different total costs in the short run as in the long run, which implies that they're changing something about their method of production when they have more flexibility in the long run. Part D of the question says, starting from producing 2 units, Consolidated's managers decide to double their production to 4 units. So they simply double all of their inputs in the long run, comment on their managerial skills. So, okay. Again, how can we think about this? Sort of an open-ended question. So if I start looking at these, costs at a quantity of 2, right? So what we can say here is that in the long run, what I notice is it costs $400 to produce 2 units, when it costs $495 to produce 4 units. So it must be the case that we're not actually using twice as much stuff to make 4 units as we are making 2 units, right? Because if we were literally using twice as much of all of our inputs, our cost, assuming that we can get as much of those inputs at the same price per unit, right? That we're not driving up the cost of labor and capital as we're trying to purchase more and we're not getting volume discounts on capital. If we just assume that away for a second, we can say, well, if we're trying to purchase twice as much labor and capital, it's going to cost us twice as much. So if we think about the particular wording here, it says, well, if they're doubling all their inputs in the long run, that would imply that to go from a quantity of 2 to a quantity of 4, they're going to turn their cost from $400 to $800. And you're like, well, wait a minute, that's kind of stupid. Because if you just rearranged the way that you were doing things and you actually thought about the least cost method of production, you could optimize your mix of labor and capital and actually produce those 4 units for $495 rather than for $800. You could save yourself a lot of money, but you're not thinking about that because you're not thinking about how long-run costs actually work. So I would argue that the managerial skills are not particularly stellar. The last part of the question asks, over what range of output do you see economies of scale, diseconomies of scale, and constant returns to scale? So the first thing we need to do is we need to think about, well, what are actually the definitions of those terms, right? And what do we need to know in order to evaluate this? So the first thing that you need to know is that economies of scale, diseconomies of scale, have to do with how long-run average cost is changing as quantity changes. So if we're going to look at that, the first thing we have to do is actually calculate long-run average total cost. So we can do that. It's pretty easy. I actually already did it for you over here. So we can say long-run average total cost is just our total cost in the long run divided by quantity, right? So what we did over here, notice I put these horribly marked arrows, that these guys were all our short-run costs. And we notice we had, our average costs here, we just took the equivalent short-run cost and divided by quantity. But now we're taking the long-run total costs and dividing by quantity, and we're getting these numbers that we see here. For example, at a quantity of 2, our total cost is 400. Divided by a quantity of 2 gives you 200. At a quantity of 7, long-run total cost is 700. Divided by a quantity of 7 gives you 100, and so on and so forth. So now we can answer our question by just pretty much directly looking at these numbers. And we can say that a firm is experiencing economies of scale when their long-run average total cost is declining as quantity increases. We can say that a firm is experiencing diseconomies of scale, if being bigger is more expensive on average, or if our long-run average total cost is increasing as quantity increases. And lastly, we can say that a firm is experiencing constant returns to scale if its average total cost in the long run is not changing as its quantity changes. Interestingly enough, that last definition requires a little bit of an assumption that's sometimes swept under the rug a little bit. That returns to scale technically has directly to do with production and not cost. So technically speaking, the definition of constant returns to scale is if you scale up your inputs by a certain amount, you're scaling up your output by the same amount. So for example, if you're doubling all of your inputs, you're doubling the output that you're able to produce. And in order to bring that back to the definition of constant returns to scale in a cost sense, you have to assume that you can keep getting your labor and capital for the same price as you did before. That trying to purchase more labor and more capital isn't either driving up the price or giving you a volume discount. But if you assume that, then constant returns to scale does actually mean that your average cost isn't changing as quantity changes. So here, we can say, well, for a while, as we're getting bigger, as we're producing a larger quantity, our long-run average total cost is going down. So we can say that this is the region where we're experiencing economies of scale. Maybe even, up to this point here. But then we notice after that, our long-run average total cost kind of flattens out. And where our long-run average total cost is flat is where we're exhibiting constant returns to scale, right? So we can say here, we're getting constant returns to scale. And we actually don't see anywhere for this particular production process and for these particular quantities where we're exhibiting diseconomies of scale. I almost used the wrong term. Because we don't see anywhere where our long-run average total cost is actually increasing as quantity increases. That said, if we were to keep writing out our long-run total costs for larger and larger quantities, we would probably get to some quantity where average total cost in the long run started increasing as quantity increases. We just don't see that specifically here.